Okay, today, or in this video, we are going to look at how to use an arrow diagram to graph the transformation of a known parent function. I've kind of set up a problem here. We're going to transform f of x equals the absolute value of x by reflecting it over the x-axis, then shifting it left 2, and then vertically stretching by 5. So we will build the arrow diagram first. We always start with our parent function. So the parent function is absolute value of x. So we'll put the absolute value parent function on there, remembering not to put anything in those set of absolute values because it's making reference to attaching those or performing that operation to whatever would happen to be on this input side over here. So now we do our arrows. We look at the first one, or our transformations. Reflecting over the x-axis creates a horizontal, or sorry, a vertical change. When we do that, vertical is output, so that creates an arrow on the output side, and reflection is a sign change. So that's what that arrow looks like. Our next one says shift left 2. Left is a horizontal motion, so that attaches an arrow this direction on the input side of the parent function. And then finally we have a vertical stretch by 5, which obviously is a vertical thing, is the output. So that's an arrow on this side, and that's multiplication by 5 on that side. Okay, so how does this help us graph this function? Well, what we need is information from the parent function. We know some things generally about the absolute value function. We know that when we put a -1 in, we get a 1 out. If we put a 0 in, we get a 0 out. That's an especially important point on the parent function because that's where the vertex is. And we know when we put a 1 in, we get a 1 out. So just to kind of sketch the parent function on here, because that's fairly important as well to understand why we chose the points that we did. And we chose those particular points because if we know where the vertex is and we know where at least one point on each side is, then we know how to sketch the graph of that. I'm going to try to fix this graph here a little bit by moving that where it belongs. So we know that that's what the graph of the parent function looks like, and that's why I chose these points that I did. Now we're going to use the arrow diagram to transform these points. The blue arrows that are over here are acting on the outputs of the parent function. The first thing it says to do is change the sign on everything that was at the beginning of this arrow. So that's the 1, 0, and 1. We change the signs on those. They become -1, 0, and 1. The multiplication by 5 arrow says multiply everything at the beginning of the arrow by 5. So it is now acting on the -1, 0, and -1 to give us a -5, 0, and -5. On the input side, the red arrow is acting on the inputs of the parent function, and it says, we didn't put what that was. It was shifting left 2, so that is subtracting 2 because left is where the negatives are. And that says subtract 2 from those things that are at the beginning of that arrow. So -1 minus 2 is -3. 0 minus 2 is -2, and 1 minus 2 is -1. And now I have a new set of inputs at the very beginning because our transformed function, again, this one big arrow, this represents G. And it has inputs that we've recorded of -3, -2, and -1, and corresponding outputs of -5, 0, and 5. So we put a point at -3, -5. We have a point at -2, 0, and that is where the vertex will be. And we have a point at -1, -5. And that gives us target directions for what we're doing. I'll do this in red over here so that we can see that. And that's a really big red line. And let me see if I can shrink those lines up a little bit, if that's not what I was looking for there. Make that a much thinner line. There on the end, and that one as well. And so that is where the transformed function goes. If I wanted a little bonus information that I can actually get out of this, if I know in my parent function that the domain of the parent function, which is about the inputs, is all real numbers, and the range is y greater than or equal to 0, well, there's nothing really I can do to change the all real numbers just by the basic transformations. So it will continue to have a domain of all real numbers, but this blue arrow, the first blue arrow, acting on the y greater than or equal to 0, says make a sign change, and we know that if we multiply or divide both sides by a negative number, then it changes the direction of the inequality. So we now have y less than or equal to 0. And if we multiply 0 by 5, we still have y less than or equal to 0, so it also captures the domain and range of the transformed function for us. We could write, of course, the equation from this, but that's included in another video, and in the effort to try to keep this short, we'll go ahead and stop this one right now.